Okay, so we've been talking about this empirical rule and the bell curve. And the weakness, as we pointed out, is if a number falls in between one of these standard deviation steps, you really can't figure out the percent. So there's another tool that works similar to this called a z-score. And what a z-score does is tells you how many standard deviations above or below the mean a number is. So the formula for the standard deviation, or for the z-score, I should say, the formula for the z-score is the z-score is found by taking the number minus subtracting the mean, then dividing that difference by the standard deviation. So up above there, we said we had that $130,000 house. Well, we had a mean of 118,000, a standard deviation of 18,000. That $130,000 house would have a z-score of 130,000 minus the mean of 118,000 divided by the standard deviation of 18,000. So the first thing we do here is we'd subtract. The 130 minus the 118 is 12,000. Then we divide by that standard deviation of 18,000. 12 divided by 18 is 0.667. Or 2/3, yep. So what that is telling us is the 130,000 that's positive here is 2/3 of a standard deviation above the mean. So it's not quite, it's less than one standard deviation above the mean. Now the real strength of a z-score, the reason that z-scores are used is you can compare two things, two items, we'll say, from different populations. What does that mean? Well, let me give you an example. Let's go back to buying a home again. And let's say you have two different areas you would like to move to. In area 1, we're going to call it area A, the mean for that 3-bedroom, 2-bath house still is what we just saw. That 118,000 with a standard deviation of 18,000. In area location B, let's say it's a little bit more of a secured community, close to a police station, so you're fire station, so you got protection. The mean price there is $143,000 with a standard deviation of $16,000. And let's say you have narrowed your search down to 2 homes. You found a home in area A that is priced $140,000. You found a home in area B that is priced at $163,000. Which one is a better deal? Well, we find the z-score. The z-score for this first house is 140,000 minus the mean, which is 118,000, divided by the standard deviation of 18,000. So subtracting there, 140 minus 118 is 22. 22,000 divided by 18,000 is going to give us what? 1.222. Yep. Over here on the other side, our $163,000 home, the z-score will be 163,000 minus what? That mean is 143, yep. Divided by that standard deviation, 16,000. So we subtract here 163 minus 143. That house is only $20,000 more than the mean. This one was $22,000 more than the mean. But the standard deviation is only 16,000. We divide that out. 20,000 divided by 16,000 is 1.25. This house here is 1.25 standard deviations above the mean. This one's 1.222. This one's more expensive compared to the other houses in its area. This one is not quite as expensive. Now it also tells you those z-scores are really, really close to the same, aren't they? 1.22.
They seem really close.
Yes, they are. And that's what it's saying, is these houses are really, really close to the same compared to the houses within the neighborhoods they're at. This one is slightly less expensive. But the question is, if you really prefer this neighborhood, there's not enough difference to really sway your decision. This can be used for, starting wages, stuff like that. Used for testing. Let's say when you got into school here, you had to take your tests. Let's say you took your math test and you got a score of 58. And on the English test, you got a score of 66. Does that mean you're better at English than you are at math? Well, no, they weren't the same test. Now, if two people took that test, let's say two people took the math test and one scored a 58 and the other scored a 66. Yes, the person with the 66 did better on that math test because it was the same test. But these are two different tests. So to compare how you did on each of those tests, we need some more information. Let's say that the mean for the math test is a score of 50. With a standard deviation of, I don't know why I put 50,000 there. The score of 50 with a standard deviation of 4. Right, so I'm just used to writing those zeros from the home loans right now. The score on the English, the mean score on the English test is 56 with a standard deviation of 6. So which one's more impressive? Well, right now I want you guys to find the z-score for each of those. Okay, so for the math, our z-score is going to be what?
It's a 2.
So yeah, 58 minus 50 divided by 4, which is 58 minus 50 is 8, divided by 4 is 2. Yes, that is a z-score of 2. For the English, how do we find it?
66, subtract the 56, and then divide by 6.
Okay, so 66 minus 56 over 6. 66 minus 56 is 10. Again, at first glance, you're 10 points higher than the mean, and over here you're only 8 points higher than the mean. But we have to divide by a standard deviation of 6. This is 1.67, or 1 2/3. So you scored a full 2 standard deviations better than the mean on the math test, and only 1 2/3 standard deviations better than the mean on the English test. So your math test is a more impressive score compared to the other scores on that test.
Must be tech English.
There you go. One more example here of how this might be used. I mean, entrance tests, probably analyzing that isn't the most useful thing you do tonight. But let's say you're a manager at a retail store. You have several departments. And you have narrowed it down to 2. You need to get rid of a salesperson. And you have it narrowed down to 2 people. So we're going to call them Pat and Peyton. You decide that next week, whoever has the lowest sales has to go. Pat has sales of $1,200. Peyton has sales of $2,800. Does that mean we're saying goodbye to Pat?
No.
No. Pat is in toys. And for last week, the mean sales for all people in toys was $2,100. With a standard deviation of $400. Peyton is in electronics. Last week, for all salespeople in electronics, the mean sales was $4,000 with a standard deviation of $500. So let's find the z-scores. For Pat, Pat's z-score will be 1,200 minus 2,100 over 400. Well, 12 minus 21 is a negative 900 over 400. So that's a negative 2.25. So Pat's z-score is a negative 2.25. What's the negative telling us there? He was below the mean. The z-score of the mean would be 0. Anything below the mean has a z-score negative. Anything above the mean has a z-score positive. For Peyton, the z-score is going to be 2,800 minus 4,000 over 500. Bless you. So 2,800 minus 4,000 is a negative 1,200. Divided by 5, that's a negative 2.4 standard deviations. So who was really worse? Peyton was more standard deviations below the mean, negative 2.4 compared to negative 2.25. So you can see how this is a very useful tool. You compare things that are not necessarily related by what you're doing is you're comparing them back to their own population and seeing where they stand within their own population and comparing that position to each other.